Uh, Howdy, howdy, everybody. I don't know how long we'll be doing this today. I don't know how well I will be answering questions today because I'm very sleepy. I got like 4 hours, maybe 4 hours of good sleep, and then like maybe 2 hours of disturbed sleep after that. So we'll see how long I last. I am very sleep deprived. So yes, I am sleepy. And actually, my wife just got home with some Thai tea, so hopefully that will help. So why don't we get started? And I imagine that she'll probably bring it in a moment. Sorry, I'm also, yeah, you know, the lack of sleep gives you a headache, that kind of thing, so that's not fun. Anyway, let us begin. I don't see any questions. No, it's Thai tea. Thai tea indeed. And you know whose fault it was that I woke up at 4 in the morning? It was my cat's fault. Mathematical physics equals theoretical physics. No, these are different things. At least, in some sense, they're different things. The idea is roughly that mathematical physicists are closer to mathematicians. They do more formal proofs than theoretical physicists will. You can think of theoretical physicists, and this is a joke, of course, but you can think of theoretical physicists as vibe coders that kind of just do physics by the seat of their pants, whereas mathematical physicists are going to be a little bit more careful. Not to say that theoretical physicists aren't careful, but you know, there's a little bit more mathematical rigor behind what mathematical physicists tend to do. And we have our Thai tea. Now I have to stir this and, you know, do that, but all right, let's answer some questions. How did you deal with the exam period when you had so much going on? You mean like in university? I just, like, I don't know, I just studied for the tests and then took the exams. How much chem do you guys take? I didn't take any chemistry. I've taken like 0 chemistry classes, maybe 1 in high school. I wouldn't trust you to deliver me a newspaper, let alone any true insight. Well, that's a strange thing to say to somebody that you don't know, especially somebody who actually has like experience and knowledge in a particular field. Who else is excited about lambda CDM anomalies and the research that will follow? Me! I'm super excited about it. Do you feel inferior to mathematicians like you feel superior to chemists? Well, considering that like I moonlight as a mathematician, not really. Like most of the people I hang out with are mathematicians. So yummy. Have you worked in the private sector before? No, not in like any sort of formal way. Jet fuel can't melt steel beams. Yeah, well, steel beams can't melt jet fuel, buddy. Do you use an e-reader? No. I have a question. When I was a kid, I heard about white holes, the basic concept being at the end of a black hole, inevitably all the matter and energy is spit back out. Thoughts? It's not really a thing. And it's not like at the end of a black hole, it's just that it's like the time reversed version of a black hole, but we don't really have any reason to think that these things exist. No organic chemistry. Literally, as part of a physics degree, it doesn't require any chemistry. What's your total level on RuneScape? Well, I'm maxed out as of Necromancy coming out. I haven't played really since I maxed out Necromancy. I got a member. I didn't see. That's weird. What's your beef with chemistry? I don't have a beef with chemistry. I just never took it. Mathematicians are so boring to talk to. All they talk about is metal and rock music. Well, that's not true. They often talk about mathematics too. Steel beams melted my father, Blitz. I'm still trying to seek vengeance. True. Makes sense. I I have a possible quantum physics discovery and a bunch of research to back it up. What now? Well, you could either write it up into a paper and then submit it to a journal and see what happens, or you can put it on hold. You can go to school for the topic, or you can, formally educate yourself, actually dive into the physics literature until you understand it, and then make sure that your paper, that your research is good, and then submit it. The research isn't going to go anywhere. What's your opinion on a new kind of science from Stephen Wolfram? I don't take it seriously, and not a lot of people do. From Lord Lumen is poo. With the $5, thank you so much. Me, what kind of movies do you like? Her, the kind where I need a tissue after. Me, really? Me too. Lord. Inappropriate. How do you have time to max out on RuneScape while doing physics research in these streams? I haven't played RuneScape in several years. I maxed out in Necromancy. I finished Necromancy like a few months after it came out, and then I just stopped playing. John Gotti questioned your physics in a recent video. I don't know who John Gotti is. Who's John Gotti? Is he on TikTok? John Gotti. John Gotti was a what? What was before the Big Bang? We don't know. We don't even know if there was a before the Big Bang. Is it not taken seriously due to the lack of evidence? Well, it's not taken seriously because it's not really using like a framework that a lot of people are. It's not really like. Look, in order for your research to be taken seriously, you kind of have to engage with the existing physics literature, and it's not really doing that. From Jack Fetter with the $5, C cat equals nocturnal, H human equals diurnal, C plus H equals FB. No, stop it. Why are you guys doing this? From Clown Meat with the $2, are we living in a black hole? No, I don't think that we are. And I don't really think that there's any evidence that we are either. Best book to learn a deeper understanding of the cosmos. I would recommend A Brief History of Time by Stephen Hawking. It's just a good book. How do I begin to learn the math behind physics? Well, you basically have to start where your mathematics knowledge ends, right? So if you only got through algebra and you struggled with algebra, go back to algebra and relearn it. And then you'll have to learn calculus, or then you'll have to learn geometry and calculus and trigonometry and linear algebra and differential equations. And then you'll be well equipped to learn the mathematics behind the physics. Sorry, if I'm not speaking super clearly, it's because I have a gnarly headache. How did you get a swear into a super chat? I have no idea. From Lord Lumen is poo with the $5. Allow me to introduce myself, Sir Lord the Reverend Illuminus is poo. Oh, it's Lord Illuminus is... Sorry, Sir Lord Reverend Illuminus Poo, PhD, leader of the Illuminati, world's strongest man, and Times Person of the Year 2011-2016. I love it. I love that for you. Very interesting guy. Have you seen the Navy patent on the craft using an inertial mass reduction device? Yeah, there are patents on a lot of things. It doesn't mean that those things exist. That's the unfortunate reality of the world that we live in. Do you know anything about quantum computing, physics behind holding the state? How do we do math with it? I know a little bit. I mean, at the end of the day, quantum computing is just you take some quantum state and then you apply transformations to it, and that series of transformations is an algorithm. So depending on what your initial state is, you have a certain final state. Now, if your question is the physics behind holding the state, like keeping the state from decaying, that is just very, very talented experimentalists who have learned to maintain quantum coherence. That's something I don't know a lot about. Is there any theory in physics that even you have difficulty understanding, and if so, which one? Topological quantum field theory is a good example. Big crunch or heat death? There are so many other options. Do you think a foundational being exists? Not really. From Lord Illuminus Poo, Google Times Person of the Year 2011. All right, we're doing it. Times Person of the Year 2011. It was the protester. It was not Lord Illuminus Poo. From Clown Meat with the $5. I don't understand the universe being at a hot, dense state. Is there a better way of explaining this? Is it like being in the center of the sun? So look, it's sort of like that. the idea is merely that the universe is cold and not very dense right now, right? Like, it's pretty cold. But if you bring everything closer together, it will be denseless, right? And it will be hotter, because when you take a gas and you compress it without letting that heat go anywhere, it gets hotter. And so just imagine like the entire universe being filled with like a hot plasma that's super dense. That's what it would be like, which is something like the core of the sun. From Jack Fetter with the $5, my cat is sending $5 to your cat. I'll let her know. Topological is rough, that abstract algebra is dense. Yeah, look, I guess you could say I'm probably more of an analyst than I am an algebraist. So and I like took a few semesters of abstract algebra, like grad level abstract algebra, and like I did well on them. It's just like all of the, you know, the BRST operators, and, you know, all of the, I don't know, what are the other words that are used in that course? Vertex operator algebra, like all of this stuff is just, I was very confused and very lost. From Lord Illuminous Pooh, my apologies, it was Times Person of the Year 2006. In 2011, I was confused. Google Person of the Year 2006. Okay, Person of the Year 2006. It was me. It was me, not you. It was me. A Brief History of Time was a difficult book for me to understand. I generally understand what I read, or at least I think I do to some extent. Yeah, so that, I haven't read, maybe I should reread it. It's been a while since I've read it, but I definitely have read it twice. Once as a child, as like a youngish child, like I was 10 or 11 or 12, and then I read it again as like a college student, and I liked it both times, so. Why are black holes so mysterious? They're mysterious because it's really hard to figure out what's going on the inside. Because the way that we typically get data to learn about the way things behave is we look, you know, we receive information from, you know, from the inside of the thing. For example, if we want to study the human body, one of the best ways is to, you know, use a CT scan or an MRI or an X-ray of some kind, or do surgery or dissect cadavers, because then you can actually look inside. You can learn better stuff about what's going on inside than just by looking at like the outside, the exterior. But for a black hole, kind of by definition, there's no way to get information from the inside of the black hole to the outside. And so it's really hard to figure out what's actually going on inside, because we just don't have that information. From Julius Anderson, thank you for the $2. I appreciate that. Why can't we find a solution to the Navier-Stokes equation? Well, look, the Navier-Stokes equation is super nonlinear. And it's, well, yeah, it's super nonlinear, and that's really, it's not just nonlinearity, it's also the fact that it's, well, I guess chaotic is a result of nonlinearity. It also doesn't have scale, or it doesn't have scale preserving behavior. At the end of the day, the physics behind the Navier-Stokes equation is such that large scale disturbances can dump energy into small scale disturbances, which can dump energy into even smaller scale disturbances, and vice versa. And so there's just no approximations or there's no easy approximations that you can make to try to control and understand the behavior of the dynamics easily. Now, this isn't to say that we can't find solutions to the Navier-Stokes equations. Given certain conditions, we absolutely can. It's just the issue is that we can't show that there exists global uniqueness, or that there's global existence and uniqueness of solutions in all cases. That's the hard thing. We don't know how to do that. It's not to say it can't be done, we just haven't done it yet. Why is physics either the easiest subject or the hardest subject? I don't think that that's true, though. Like, I think that it just varies in difficulty depending on the person. With new data showing dark matter losing acceleration, is the Big Bounce crunch more plausible now? So you're thinking of dark energy. But yeah, this is it. It at least puts it back on the table. From Austin Clegg with the 15 shekels, is there some way to theoretically get information from the inside of a black hole, or is it completely impossible? It depends. So classically, it's completely impossible. However, in principle, maybe you can learn something via Hawking radiation. Hawking radiation is in some sense related to the interior of the black hole. This is kind of like the very slow energy leak that comes out of a black hole. So there's perhaps something that you can learn by analyzing like the specific quantum configurations of the Hawking radiation, but that is far beyond our technological capability at this point. I'd like to speak with you privately. Mind-blowing info for you. I'm sure it's probably nothing, so I'm good. Does the geometry of space invert around a black hole like a reverse bubble, and the event horizon is the edge? The geometry of space doesn't invert. What happens is that a space-like direction becomes a time-like direction, and vice versa. How about a camera with a rope? The rope will break. Time stops at a black hole? Not really. Observed time for someone falling in from the perspective of somebody far away stops, but that doesn't mean that somebody can't actually enter the black hole in finite time from their own perspective. From Very Good Wizard with the $5. What's the distinction between Everettian quantum mechanics and many worlds? And is there a possible world where you don't have a headache? Feel better soon. In some sense, there's not really a distinction. Many worlds is just kind of the bastardized notion, but they capture the same ideas. What's Dr. Blitz's perspective on Eric Weinstein's theory of geometric unity out of curiosity? It's a hack job. It's like not good science. Nobody in the scientific community takes it seriously. From Fatesify with the $5, do you believe in the physical collapse of the wave function? Why or why not? If you do you believe in Penrose's theory? So look, I lean against it. I don't necessarily think that physical collapse happens. And the reason for this is that it seems like, so people have looked for dynamical collapses. These are dynamical collapses like, is it GZW? Is that what it's called? I can never remember what the acronym is. It's GRW, I'm sorry. The GRW dynamical collapse model is like a model that people have proposed for how collapse can happen statistically. And the thing is experiments have been done, and the range of parameters that like describe the collapse have been shrinking and shrinking as the experiment's been done, because we keep not seeing the collapse phenomenon actually happen. We keep not like detecting the actual collapse, we just keep detecting the end result. Similarly, as far as I know, Penrose's model of collapse, gravitationally induced collapse, hasn't been demonstrated either. And the standard Copenhagen interpretation collapse just doesn't even have a mechanism, it's just magic. So I lean towards collapse being an ad hoc addition to the theory, and it probably isn't necessary. Why is electric and magnetism so easy, but circuit analysis so hard? I actually think it's kind of the opposite. Circuit analysis is a very rigid structure, whereas E&M can be so complicated, because it's so much more loosey-goosey. You think we can get through the Van Allen belts? Yeah, it's really not that hard. Like, humans are pretty radiation resistant. Like, you wouldn't want to live in the Van Allen belts, but if you spend like an hour in the Van Allen belts, you'll be okay. In many worlds, how to physically conceive of other branches? Where are they? Well, they're here. Look, so at least if you take the universal wave function interpretation, space is part of each branch. It's just so they're not spatially distant from each other. They each have their own space. Is there always be smaller than smallest and bigger than biggest? Not necessarily. There could just be a minimum, like a fundamental thing. Are you familiar with Roger Penrose's current hypothesis for the Big Bang entropy problem, eons, etc.? He uses the Escher picture, angels and demons. Yes, I'm very familiar with it. I wish it were true, but it's just probably not. What does it mean when superstring theory covers 10 dimensions? What it means is that there are 9 spatial dimensions in superstring theory. So there's the 3 normal ones that we're familiar with. And then there's 6 curled up tiny dimensions that we can't access because they're too small. And then there's 1 time dimension. It literally means that there's extra directions that you could travel in if only you were small enough. Is there a schedule for your lives? I want to know when you do Flurf lives. I usually do them on Mondays. Mondays at 9 a.m. Mountain Time, which is 11 a.m. Eastern Time. Well, he uses pictures of angels and demons to guess at science. It sounds quacky. No, so look, the point is that there's a picture I can show you by Escher, I think. It's a very famous picture, by the way. So like it's like an engraving or something. it's this. And the point is that the geometry of what's happening here is very, very similar to the geometry of something called, or very, very similar to something that's called conformal geometry, or in this case, it would be a conformally compact manifold. And so, like that's a very important idea. Conformally compact manifold is an idea that Roger Penrose helped. Like the mathematics behind conformally compact manifolds is an idea that Roger Penrose is instrumental in developing the theory of. And the point is our universe actually behaves a little bit like that. It actually does look like it's conformally compact, at least if you allow the universe to expand forever. And so this is not like the way that he figured out how to do physics. It's just like a nice analogy or a nice visualization. And it's just like an etching by Escher. Penrose is actually really influential on Escher, I think, or maybe the other way around. Maybe the other way around. I mean, like a lot of these like absurdist Escher things, you may have heard of them. There is a Penrose staircase you may have heard of, which a lot of people think of as like an Escher thing. Despite, yeah, actually, so Penrose and his father actually inspired Escher to create this illustration. So this illustration is called is like, you know, you have the people that are always walking upstairs, but they never get to the top. They're just always walking up. That is a result that was inspired by this, which is a creation of Roger Penrose and his father, Lionel Penrose. They came up with this thing. So, I mean, Penrose inspired Escher, Escher inspired Penrose. There's a lot of back and forth there. It's very interesting. From Ken with the $20. Thank you so much, Ken. What's up? Hope your day is going well. I have a headache, but the tea is helping, to be honest. It's not an optical illusion. It's a so-called impossible geometry. Is it possible to change the outcome of a horse race by measuring it? Only if they finish in a quantum finish or something like this. Have you heard an MIT graduate found and defined time crystals? Have you heard of them? I have, but time crystals are much, much older than something recent. Time crystals date back to, is it Frank Wilczek? Yeah, it's Frank Wilczek, who I've met, by the way, who is not a graduate of MIT. He is a professor at MIT. So he actually graduated from Princeton. But a time crystal is a lot like a spatial crystal. A spatial crystal is periodic in space, meaning that it repeats every certain amount of distance. A time crystal is a quantum system where the quantum state is periodic in time. Scroll down a little bit. Dr. Blitz, were the fundamental constants different during the Big Bang? Is it linked to symmetry breaking? Well, look, so what we think of as fundamental constants, things like the fine structure constant, these probably weren't different. Okay, well, let me back up. It's not clear. We don't actually know why the fine structure constant is the value that it is. It's possible that the fine structure constant was the fine structure constant, you know, roughly 1 divided by 137, even in the very, very early universe. However, the fine structure constant controls the behavior of electromagnetism at very low energy. At higher energies, the effective fine structure constant changes. It gets bigger, actually. But that doesn't mean the fine structure constant, which is the asymptotic limit at low energies, changes. I made a video on muon tomography. Would appreciate a stitch to explain it further. Oh, that's neat. Let me pull it up and I'll add it to my to-do list. Mr. Earth Guy. God, I feel ancient right now because my thumbs are not doing what I want them to do. I don't see it. Tag me in it. Tag me in it or send it or DM me or something like that and I'll take a look because I don't see it on your page. Can you do a video on spacetime manifolds? I have so many videos on spacetime manifolds. So many. See, to become a PhD in physics, did you have to prove something? Yeah, I proved several theorems, actually. Oh, you tagged, oh, okay. You did tag me, it's just uploading. Okay, I'll take a look. Same with 3i Atlas, nothing magical going on there either. Exactly, it's just a comet from another solar system, but it is just a comet. Why is quantum energy in my business the way it is? Like, how does it know what I'm looking at? It doesn't. That's not what it is. That's not how it works. Are my videos here or on YouTube? All of my short form videos are on TikTok. Sometimes they also get uploaded to Instagram and YouTube, depending on what kind of content they are. I don't upload debunking stuff to Instagram. I upload my science content, if it's less than 3 minutes, to YouTube Shorts on the Blitz PhD account. And I upload my debunking content, if it's less than 3 minutes, to the Dr. Blitz Debunks account on YouTube. What poison are you drinking? This is Thai iced tea. No new breakthroughs in modern physics. Cool, we'll check in 100 years from now. Why do you think that there's no new breakthroughs in modern physics? It's a really weird claim. What is my area of physics? So I do mostly relativity, which so like I dabble in cosmology a bit. I'm trying to get deeper into cosmology, actually. I also do some holography stuff. I've dabbled a little bit in quantum gravity, but I also do some pure mathematics as well in conformal geometry. I'm into biology. All science is interesting, though. What's new in physics? Well, I mean, physics is huge, right? I mean, biology is huge. Like the whole what's new in XYZ is really hard to answer. But like there was a, in fact, like I could just show you. There are papers that come out literally every day, like dozens of them that appear on the preprint server that are just, you know, waiting for peer review. So there was a there was a discovery of a galaxy without stars recently. This was kind of neat. I heard about this like a week ago. It's just dark matter and dust. So that's really cool. They called it Cloud 9. If you're asking for like in the last few years, like big breakthroughs, there was an observation that dark energy doesn't seem to be constant anymore, or at least it doesn't seem to have been constant ever. That was a huge breakthrough because that'll inform on what happens into the future of that informs on the way that we understand the future of the universe. So from Tina we have you heard of the no gravity for 7 seconds? That is supposed to happen in August. Go watch my latest video, Tina. Dr. Blitz, some physicists used to believe a single electron exists everywhere since they all look the same. Why didn't they believe the same for the neutrons and protons if they are identical too? Well, this wasn't like some physicists. This was like 2 guys. And I don't know, maybe they did think that. If we can't see electrons, how do we know they exist? Well, we can't see anything except light, but like we know other things, like we know sound exists, but we can't see sound. We can detect when neutrons interact or when electrons interact with things. There are various compounds that if you fire a neutron at it, sorry, can't talk. If you fire an electron at like a film, a certain kind of film, it'll make a bright flash. And so then we can detect that the electron is there. Will humanity ever reach type 1 or further civilization? Maybe. Does he even read YouTube chats? Yeah. Do you have any book suggestions for people who want to start learning about physics? You could read The Biggest Ideas in the Universe. It's a 2-volume set, and I think the 3rd volume is coming out soon, by Sean Carroll. Why does everyone believe an interstellar rock is aliens? I don't know, because Avi Loeb said so, and he has a lot of airtime in the mainstream media, I guess. What would an extremely hyperbolic spatial dimension look like? Well, I don't know what it means to be extremely hyperbolic. But generally, the way that you can embed hyperbolic spaces into larger spaces is that they look like Pringles or saddles. So a 2-dimensional hyperbolic space embedded in 3-dimensional Euclidean space just looks like a Pringle that extends in all directions. Dark energy matter flow explained in their entirety. Okay, no, don't shield for yourself, Ian. Is it possible to make the mammal... What's your perspective on the theory of loop quantum gravity, out of curiosity? I'm not super well read on it. I know more about string theory because, you know, as a graduate student, I had to take 2 courses on string theory. I didn't take any courses on loop quantum gravity, so I just don't know as much about it. I have read a bit. I read a pretty comprehensive review on it a few years ago, and it was really compelling. Like, they made a really good case for themselves. So I'm definitely not going to say that. It's like nonsense. Who are your favorite well-known science communicators for physics? Sean Carroll, Matt O'Dowd. Those are the 2 best, in my view. Neil deGrasse Tyson does a good job, but I think that he could be a little bit more rigorous and he could go into a little bit more complicated topics. Physicists, Dr. Blitz, do you know any programming languages? I know Python. That's good enough, I guess. Are black holes real or just a theory? They are absolutely real. Absolutely real. Replica wormholes, real space-time objects, or bookkeeping devices in the gravitational path integral. We have no idea if they're real space-time objects at this point. Also, to be clear, the gravitational path integral may not be the correct way of doing quantum gravity. Will dark matter help me get a job at Walmart? Probably not. No. String theory was a waste of time, wasn't it? No. There is so much we know now because of string theory. You should totally do a joint thing with Matt O'Dowd. I would love to do a joint thing with Matt O'Dowd. I would love to. I don't think he knows who I am. Do you like Brian Cox? I just don't watch his stuff. Brian Cox is like the British Neil deGrasse Tyson in my view. Have you read From Eternity to Here by Carol? I don't think so. If Earth is not flat, why doesn't a ball roll anywhere when you set it on the ground? Because of gravity, Jason. Because of gravity. Does the electron field exist where the probability of detecting an electron is 0? How is it formalized? Yeah, it exists. The electron field is defined to be everywhere. It can't not be everywhere, otherwise it wouldn't be a field. Why should we take you seriously when you believe in sphere Earth conspiracy? Good question. You shouldn't. The Earth being a sphere is a conspiracy. Absolutely, you're right. You got me. What has been learned from string theory? Well, the entirety of the holographic principle, all of that stuff about like, you know, gravity being related to, or like space-time being emergent, or gravity being related to quantum field theory on like a holographic boundary, all of this stuff about the entropy of black holes, all of that comes from string theory. Well, the entropy of black hole stuff doesn't come from string theory, but it was kind of explained by string theory. Yo, Dr. Blitz, do rockets for space travel use fossil fuel? Are we close to fusion? I don't think that they... Okay. It depends on what you mean by fossil fuel. I think that, like, they don't just run on gasoline, but they do often run on, like, kerosene, or, like, hydrogen. And those are technically, like, organic compounds, hydrocarbons even, except hydrogen. Hydrogen's not a hydrocarbon. So in some sense, they do, if they're running on, say, kerosene. Is the ground actually accelerating up? That's one interpretation of it, but like these are not all, like all of the interpretations are just different ways of viewing the mathematics. Do physicists need beyond bachelors? Yes. What is, oh, I should jump down to the bottom because I'm way behind. You loving that tea? Yeah, honestly, I love Thai tea. Have you heard the theory that gravity will turn off for 7 seconds? Go watch my latest video. It's literally about that. It's completely made up. Like, this was completely made up 2 weeks ago. Why are there not as many discoveries now that are as influential as general relativity? Am I biased? You are biased. Also, arguably, like, a lot of the stuff that they did in the early 20th century was low-hanging fruit. And the reason why I say it was low-hanging fruit was because the energy scales required to actually probe and collect new data that did not align with previous models was accessible at the time. However, there's not really any good reason to think, and we don't really have any evidence that says this, that there is really any data that doesn't align with our current theories. There are a few standout facts that we haven't figured out yet. But there's nothing like, oh, we don't understand why Mercury goes around the sun in the weird way that it does. Like, that was one of the problems with Newtonian gravity that general relativity solves. Similarly, the quantum mechanics of the early 20th century, the reason why we were able to do that was because we finally were able to start probing high energy, or, you know, high energy particle physics, basically. Like the first particle accelerator was made in like the late 1800s. It was the cathode ray tube. That was technically a particle accelerator, and they could start doing physics to figure out what's going on there, and that gave rise to things like quantum mechanics. We just, like, there's no new regime of energy or of accuracy that we have access to now that will give us a whole bunch of, or that gave us a whole bunch of unexplained things. Which is why we're not seeing so much paradigm shifting as much anymore, because, like, paradigm shifts happen in bursts, right? You get a paradigm shift, and then you do a whole bunch of refining until you get some new technological breakthrough, some new experimental breakthrough that just breaks your models that you have, and then you get another paradigm shift. That's just what generally happens. Are gravitational waves composed of gravitons acting as a wave? That's one way to view them, yeah. Do you think we can ever travel with the speed of light with mass? No. Shouldn't us being able to know and distinguish qualia mean that it's physical? Maybe. You'd have to ask a philosopher. I want to make sure I didn't miss any super chats. By the way, if you want your question to be prioritized, make sure to send a super chat. That's the easiest way that I will see it, and I will definitely answer it for you. Quantum entanglement means two particles can interact instantly over any distance. Can we use it to instantly communicate across the known universe like Morse code? No. So quantum entanglement doesn't mean two particles interact instantly over any distance. That's not what entanglement is. Entanglement is a correlation between two particles. You can kind of think of it as, at least one way to think about it. It's not quite right, but it's almost right. Imagine that you buy a pair of shoes, and then without opening the box, you tell your friend to open the box, take one of the two shoes out, and then go to China. Now, by the time they're in China, you open the box and you look at what shoe is left. You instantaneously know what the other shoe was, but you didn't communicate anything. Now, it's not quite right. That assumes that there's a local hidden variable that's involved, and that's not what happens in quantum mechanics. But that's the kind of way that you can understand that there's really no communication happening. From Sakira Nalvala, I can sound things out. Thank you for the 40 real, or the 40, are those Indian rupees? Hey Doc, how do you root and justify reality and your existence as truth mind dependent? Well, that wasn't a single question. That wasn't even a sentence. But I am actually the foundational reality, turns out. From Drew Crew with the $5, would dark matter be considered in a superposition since it doesn't interact with anything? Well, not necessarily. You can have things that don't interact with things without being quantum things at all. In fact, dark matter could make sense even if Newtonian physics and quantum physics wasn't real. You would just need something that doesn't interact with electromagnetism, that's all. Why is our solar system constantly moving as if it were orbiting a black hole getting sucked in? Well, it's not moving as if it were orbiting a black hole. It's moving as if it's orbiting the center of mass of a galaxy, which it is. What's physics' next big contribution to medicine? It's hard to say. It hasn't happened yet, right? What, you expect me to predict the future? What's our relativistic speed to a fixed point in the universe? I don't understand that question. Would a wormhole be time travel? You could make it time travel, but it doesn't have to be time travel. We are orbiting a black hole. We are not orbiting a black hole. We are orbiting the center of mass of the Milky Way. From Bob Dylan with the $2, could you give a quick inertia for dummies? Inertia is merely a measure of how hard it is to get something moving. That's all it is. So the more inertia something has, the more it is to make it go from not moving to moving. Similarly, the more inertia something has, the harder it is to make it go from not moving, or to go from moving to not moving. Blitz explains spaghettification. Yeah, so spaghettification is actually caused by the same phenomenon that causes tides on Earth. So the moon has a gravitational pull, right? It pulls on things depending on how far away they are. The closer you are to the moon, the stronger the gravitational pull. That's how gravity works. Now what that means is that the side of the Earth that's facing the moon is going to have a stronger gravitational pull from the moon than the side of the Earth in the opposite side of the Earth. Sorry, than the side of the Earth that's opposite the moon. So the water that's on the close side of the Earth to the moon will be pulled more than the rest of the Earth will, because that water is closer. Similarly, the further water will be pulled less than the rest of the Earth, and so it will be effectively pulled away. So what happens is that in the direction of the moon, the water goes like this. It squeezes in, and so you get high tides there and you get low tides here. Now that same thing happens for any gravitational effect. The closer you get to a gravitating body, the more severe that stretching is. Now, typically for most things like the moon or like the Earth, you just can't get that close to the thing without bumping into the thing, right? Because the moon is, fairly big, not very dense. But black holes are very, very dense, which means that you can get really, really close to them, which makes that stretching factor, that stretching force, significantly more severe. We call it spaghettification when you get stretched out into a thin line. And from Jamie Marchant with the 100 SEK, these are Swedish krona, I believe. Thank you for the quantum entanglement answer. Very good. I appreciate that. And from Saikira Nalvala with the 40 rupees again. Why combining quantum mechanics and special relativity results in fields? It's not that it results in fields, it's that fields are necessary to explain what it does result in. What it results in is it results in particle creation and particle annihilation being possible. And then now you have to explain, why is it that you can have multiple different identical particles spontaneously popping out of existence, for example? And fields are the best explanation that we have. From Bob Dylan with $2, thank you so much. And he says, thank you. What about entropy for dummies? This one's much harder. Entropy is, put simply, it is a measure of, there's actually several different versions of entropy, but the most commonly used one, called coarse-grained entropy, is basically a measure of how many different ways the microscopic details of a thing can be without changing the macroscopic details. So imagine that you imagine that you had like a box filled with gas, right? The macroscopic details would be things like its temperature, its volume, its pressure, its mass, these things. But you could put those gas molecules, you could rearrange them, you could shake them up without changing any of that. And so that system would have a lot of entropy. So you can think of entropy as kind of like how much information you don't need in order to specify the macroscopic details of the system in consideration. Put another way, this is a measure of disorder. Is Poincare recurrence false? No, it's not false. It's like a mathematically true thing. But in order for it to be physically relevant, you have to satisfy certain criteria. Explain the photoelectric effect. Yeah. So the photoelectric effect was discovered by, what was his name? He was a Nazi scientist, actually. Philip, or it was, is it Philip Leonard? Is that his name? Yeah. It was discovered by Philip Leonard, if I remember correctly. And it was explained by Albert Einstein, which is ironic. And what the photoelectric effect is that if you have a metal and you shine different colors of light on it, sometimes, depending on the color of light, electrons will pop out of the metal. Now, what you'll find is that if you shine a red light on it, electrons will never pop out of the metal. If you shine a blue light on it, depending on the metal, sometimes you'll get electrons out. And if you shine an ultraviolet light on it, most metals, you'll pop electrons out. And so the explanation that was offered by Albert Einstein is that the reason why this happens is because the light is made of individual packets of energy. And the color determines the energy that each packet has, whereas the intensity of the light is just how many packets of energy you have. And so if you have, even if you have a lot of red photons, these are the packets of energy, if you have a lot of them, each individual photon doesn't have enough energy to knock an electron out. But if you have even just a few ultraviolet photons, each ultraviolet photon has a lot of energy. So each ultraviolet photon has enough energy to knock an electron out of the metal. And so that's why it depends on the color and not the intensity. From Stargirl with the $5, my parents' toilet illuminates 2 days per year when sun shines precisely through the window. What variables would one need to calculate their location? Like all of the details. There's so much involved there. From Bob Dylan with the $5, what are theists yapping about when they talk about the universe not being infinite because of its entropy? I've heard this brought up a few times. Yeah, so roughly the idea is that there's this thing called the second law of thermodynamics. The second law of thermodynamics says that in a closed system, and there's a lot of stuff in the details of what it means to be a closed system, the entropy of that system never decreases, right? It always stays the same or it goes up. This is a statistical thing. This isn't like, there's not some mechanism that makes that happen. It's just statistics. And so what they say is, well, you can't have a universe that's lasted forever because that would mean that the entropy would have been increasing forever, but the entropy isn't infinity right now. Therefore, it must have been, if it's finite, it couldn't have been increasing forever. Now, that's not quite right because there's a lot of ways that you could have entropy increasing forever without like leading to a heat death now. For example, you could have the entropy always be infinite and also be increasing. In the same way, like if the universe is actually infinitely large, then the entropy of the universe is infinitely large. And so even if you increase the entropy stays infinitely large. Another thing is that the second law of thermodynamics, it applies to like things in the universe. We don't really know that it applies to the universe as a whole. So there's a lot of reasons why it's probably not a particularly good argument. Usually it's just a thing that people say because they heard somebody else say it and they believed it without actually looking deeper into it. And from Sakira Navala, again with 100 rupees, in steady state model of the universe, did universe have an infinite past? That's the idea anyway, yeah. From Dav Ladav with the 2 Canuck bucks, which physics facts should people most know, in my opinion? That quantum mechanics isn't magic. That's the most important thing, to be honest, because people get swindled by that a lot. From Tim for Pele with the $5, do you ever work with algebraic topology? I was curious and began looking at some of the math and I immediately felt like the universe was mocking me. No, I never do that. Very, very scary. And from Google YouTube with the 40 rupees, it's better to be libertarian than being liberal. You can be both, it turns out. From Anarcho-Objectivist with the $2, would love to see a convo between you and Inductica. I have no idea who that is. Thank you guys for the support, by the way. Quaternions seem to be ubiquitous in physics. Could octonions perhaps offer more than what is presently used in physics? Some people are looking into this. It's a little bit fringe, but some people are looking into it. Can you explain how quantum superposition is incompatible with Einstein's equivalence principle? I don't think it is. Well, okay, let's think about this. Maybe there's a way in which it can be. Yeah, there probably is a way in which it can be, and it's kind of like a deep incompatibility. If you can have quantum superposition, then that means that a system can be in multiple different spatial locations at the same time. And so then there's questions about like the object will have a single inertia, at least, you know, if it has a well-defined mass. But it's not clear what its gravitational response will be because it's in different locations and the geodesics passing through those 2 different locations will be, you know, different. And so the gravitational mass and the inertial mass might seem to be different if you have superposition, spatial superposition. At least that's one way that you might get a incompatibility. And I've been told to plug the Discord. So yeah, if you guys are 18 years or older and you want to join the Discord server because you want to get announcements about when I go live, you want to get announcements about when I post videos, you want to get announcements about whatever, or just ask me questions or talk with other like-minded people, go to discord.gg/drblitz. Dr. Blitz. It's the special Discord invite URL. And you can join there and have a good time. From Drew Crew with the $5. What do you think of this recent paper, Tunable Einstein-Bohr Recoiling Slit Gedanken Experiment at the Quantum Limit? I haven't read it, so I don't have any opinions on it. Sorry, that's not a helpful answer, but I haven't read every paper that comes out. Isn't gravity just fake? Isn't it just density and buoyancy? No. Neither of those can account for why things fall. Why things fall down in particular. Dr. Blitz, what does a Hilbert space represent physically? Well, it represents the state of the space of possible states of a quantum system. Do we have to be mentally 18 plus for Discord or just physically? In principle, just physically, but I would hope that you are also mentally 18 plus. How does the firmament stay up there? There isn't a firmament. Can you repeat the Discord link? The Discord link is discord.gg/drblitz. Dr. Blitz. It's just the name, Dr. Blitz, but with not spelling out doctor, just the DR part. What is the difference between a black hole and a white hole? Black holes are real, white holes are probably not. What would be easier to terraform, Mars or Venus? They're both hard. It'd probably be easier to live on Venus if we're being completely honest, because we could at least, you know, hang out in floating habitats in the upper atmosphere and be relatively safe. The air pressure would be relatively normal, the gravity would be relatively normal. But we don't have the capability to terraform, period, at this point. From Saikira Navala, again with the 100 rupees, how does many worlds interpretation of quantum mechanics avoid infinities? What's the problem with infinities? And from Anarcho-Objectivist with the $2, what was the title of your doctoral thesis? I'm not telling you, because then you would know my full name and where I went to school, which I don't want to make that information publicly available. But I do appreciate the $2. Are black holes very dense objects, or are they actually holes? Look, black hole is a name. It's not really indicative of what it is. A black hole is a astrophysical object that has so much mass concentrated in such a small area that the gravity is so strong that light cannot escape from it. It's kind of just by definition what it is. What's your view on supersymmetry? My view is that while it's a beautiful theory, it doesn't seem like it's true in reality. From Demtra with the $5, is our inability to travel at or faster than the speed of light simply because we have not found something that beats special relativity? Laws of physics don't get beat. It's not really like a thing. It seems like that this is an impossibility. There's no law, it is not even a well-defined notion to go faster than the speed of light or go at the speed of light if you have mass. How would that floating things on Venus work? Well, you would use like basically, what are they called? Like blimps? Because the atmospheric density on Venus is enormously larger than it is on Earth. So the buoyant force is much, much stronger on Venus than it is on Earth. So you could have like floating habitats on Venus, even at relatively high altitudes when the atmospheric pressure gets lower. And the other thing is that like Venus is just warmer and the gravity would be more normal. So it would, yeah, you would just use like basically blimps. From Wayne Cottrell, thank you for the £5. I appreciate that. Do physicists contribute to the hard problem of consciousness? Not often. It's not really our field. Are we in the third dimension of moving through the other higher dimensions? Look, so we live in 3 spatial dimensions and one quantum dimension, or one temporal dimension. There's not really any evidence of more dimensions than that. If quantum states are epistemic, what is the ontic referent that evolves unitarily? If they are ontic, what is the referent of superpositions? So your first question is one of the reasons why I think that quantum states probably aren't epistemic. With regard to your second question, I'm not really sure what you mean by what is the referent of superpositions. Superpositions are just like a state being in a superposition is just a basis choice. Like it's an arbitrary basis choice. You can always choose a basis so that a non-entangled quantum state is not in a superposition. That's always possible. I'm not going to read your super chat. I'm sorry. In fact, YouTube chat, please ban Google YouTube 111. Or Google YouTube 111, please ban them. Is Earth round or flat? Assume I'm a flat earther. Earth is definitely round, and the easiest way to see this is merely sunsets. Sunsets only make sense on a globe Earth. Quantum may derail physics like string theory did for 50 years. String theory hasn't derailed physics. We've gotten so much good work, good knowledge out of string theory. People who say that they think string theory was a waste of time just don't really know what string theory is. Can a non-metallic object be magnetic? I need help with this question for school. Well, you can have ceramics that are, but almost everything is metallic at the end of the day. Generally, no, you have to have unpaired electrons, though, in order to have magnetism. So I would imagine that if you have something that has all of its electrons paired, then you can't have magnetism. What's some good work that came out of string theory? The holographic principle, the ADS-CFT correspondence, which is an example of the holographic principle, the black hole information paradox being resolved, black hole entropy being explained, various symmetries, mirror symmetry, R symmetry, T symmetry. All of these symmetries have found use elsewhere. Yeah, I mean, there's a lot of like new tools that we have to like do physics and do mathematics that came out of string theory. From Garba Gaiman with the 5 Canuck bucks, re-cloud cities, are there violent storms on Venus? I don't know. I imagine somebody's taken that into account. And from Saikira Navala, thank you for the 40 rupees again. You might not have the answer to this, but what do you think the Great Attractor is? The Great Attractor seems like it's probably just a bunch of galaxies on the other side of the galaxy from us. So like, look, we can look up away from the galaxy. So our galaxy is like a pancake, right? We can look above it, we can look below it with basically no obstruction. Because there's just not a lot of stars that way. But if you try to look through the galaxy, there's a whole bunch of stuff in the way. And unfortunately, that's the direction that's the direction that the Great Attractor is in, so we just can't see it. But it's probably just a bunch of galaxies with strong gravity. How did energy start in the beginning? And don't say it's always been there. Energy is not a substance. It's not a thing that needs a creation. Energy is a property of things. And it turns out in our universe, which is dynamical, which is changing with time, is expanding even, there's no well-defined notion of a global energy. It depends on the observer. What observation could falsify Earth's motion or curvature without redefining the frame? Without redefining the frame? So you mean like if you work in like... I mean, like, in order to falsify Earth's curvature, for example, one thing that you could do is you could like measure the angles within a giant triangle laid out on the Earth. And if you got exactly 180 degrees rather than like, you know, a little bit more than 180 degrees, you would find that for a sufficiently large triangle, you would get like, oh, the Earth must be topologically like planar rather than spherical. That would be a way to falsify the Earth's curvature. The thing about the Earth's motion is that it is frame dependent. From Bacon and Bush with the $20. Thank you so much, Bacon. I appreciate you. How is the -1/12 infinite sum value found in physics? It shows up in string theory. When you're doing zeta function renormalization, it shows up there. Sorry. Using flat Earth measurements to try to prove curvature. What? Okay, I don't understand that question. I don't think that is a question. What is the most difficult field area of physics in your opinion? It depends on the person. This is not like a thing that is really well defined. It's freaky when you see a triangle on a globe. Triangle with 3 right angles. Look off. Yeah, I agree. Let me show you guys what is meant here by like a triangle on a globe and why it's freaky. So this is technically a triangle. In spherical geometry, you can define what a straight line is on a sphere, and these lines, these curves here, these are straight lines. So this is a triangle on a globe, but each side or each angle is 90 degrees. These are all right angles. And yet, it's a triangle, so the internal sum of the angles is 270 degrees here, rather than 180 degrees like you learn in standard geometry. And that only happens because you were on a globe. How the planet cools when it's in a vacuum. Well, so the Earth can give off radiation. Everything gives off infrared radiation, or microwaves or radio waves, depending on its temperature. And the Earth being around 300 Kelvin or so, a little bit cooler than that, I guess, on average, it gives off infrared radiation, and that's how it can lose heat, or lose thermal energy rather. Does physics rather support or not support the idea that life might be a simulation? It doesn't support it. What is the relationship between time and gravity? So gravity, the way that we understand gravity in like the modern sense, is that gravity is a phenomenon that is best described by the curvature of space-time. Now, the leading order effects for why things fall down is merely due to the change or the curvature of the temporal dimension, how time is experienced by falling observers, or by geodesically traveling observers. And so you could say that the curvature of time is what causes most of the gravity that you experience. Gravity doesn't do all the cool shit you want it to. Yeah, it does. And if you learned what gravity was, you would actually have a good understanding of what kinds of things that gravity can do and what kinds of things it can't do. From I'm Not Eddie with the $5. What does it mean when orbitals have angular momentum? I can't wrap my head around it. I thought electrons don't move like macroscopic matter. They don't move like macroscopic matter. They still do have orbital momentum. If you're asking what that means, what it means is that if you took something with angular momentum, and like a photon, for example, photons can have angular momentum, and you had them be absorbed by an electron in an orbital, that the orbital angular momentum I should say the total angular momentum, because there's orbital and spin angular momentum, but the total angular momentum of the electron after it absorbs the photon has to be equal to the original angular momentum of the electron plus the angular momentum of the photon. From Cameron Snagoski with the $10, thank you so much. Do you think quantum scars will assist in building a fault-tolerant quantum computer? I don't even know what a quantum scar is. I'm not deep in the quantum computing literature, guys. But I appreciate the $10 anyway. Sorry I couldn't be more helpful. Is there more evidence of dark matter other than it has to be there, otherwise gravity wouldn't work? Well, it's like we see a bunch of different cases of this being the case in different ways. So on the one hand, we see, we see that galaxies rotate at a certain rate, and if there's not more matter, then the galaxies seem to be rotating too fast, and they should fly apart with the way that we understand gravity. And then also we go out and look in space, deeper in space, and we see that the amount of gravitational lensing, so the way that gravity bends light, it seems like there's more gravitational lensing than there should be, given the amount of matter that we can see. And so gravity wouldn't make sense unless there's more matter that we can't see. And then we can go back and look even further, deeper into space at the cosmic microwave background radiation. And we see that the distribution of fluctuations in the CMB only makes sense if there's more matter than we can account for. More like massive slow matter than we can account for. And so like there's several different lines of evidence that all say like, yeah, these observations don't make sense in different ways, unless there's this one thing that happens to solve all of the problems at once. So that's like pretty good indirect evidence that dark matter exists. From Drew Cruz with the $5. Thank you so much. What? Who am I getting a phone call from? Sorry, I might have to take this. Hello? All right, sorry about that. From Drew Crew with the $5. If supermassive black holes existed during the hot, dense state of the Big Bang and now, wouldn't these be considered primordial black holes? Well, we don't know that they existed back then. It's possible that maybe the seeds of these black holes existed, but the black holes didn't exist. Maybe the black holes only formed several million years after that early state. We don't know. We don't have a fully fleshed out picture of how they formed exactly. It's Neil deGrasse Tyson. He's angry. Yeah. I just watched PBS Spacetime, and they said that we would need to build a 4 light-year particle accelerator to find the graviton by particle colliding method. Any thoughts? Yeah, that seems about right. A thing I always wondered about is, do we know if universal constants stay constant over galactic timescales? Could it be that the speed of light changed over billions of years? Probably not. And the reason why I say that is because we can see distant galaxies, and distant galaxies are old galaxies, right? We're seeing them in the past. And if that were the case, then if it were the case that the constants were different billions of years ago, then when we look at galaxies whose light we're just now receiving from billions of years ago, those galaxies should look different. They should look like they obey different laws, or they have different constants governing their dynamics, but they don't look that way. They look basically the same as galaxies today do. From Sickle Steven with the 27 Swedish krona, what would you want to invent for humanity? I'm not an inventor, so like it's not something that I think about a whole lot. Why is space-time curvature treated as physical explanation rather than a mathematical placeholder? The way that we give explanations in physics is via mathematical objects, and the mathematics is at least intended to describe a physical phenomenon. And so when we say that, you know, like when we talk about electromagnetic fields, for example, these are just mathematical objects, but nobody has any issue accepting that like that the things that we describe with like electromagnetic fields are like actually things that exist, despite the fact that, you know, you can't touch an electromagnetic field. You can't see an electromagnetic field. Like you might think that you can because photons are excitations in the electromagnetic field, but even then what you're seeing is you're seeing like a neuron impulse in your brain, and that's just triggered by something that we call the electromagnetic field. It's triggered by like some sort of phenomenon. So like what you're asking at is like, what is it? Like space-time curvature could be just as physical as the electromagnetic field. There's like nothing, there's not really an issue there. You can be shocked, but still you're only feeling the neurons. What does it mean if a theory has 0 degrees of freedom or -1 degrees of freedom, like 2D gravity? Well, so when we talk about degrees of freedom, it's just how many different, generally, when we're talking about degrees of freedom, we're talking about the number of propagating modes, like the number of propagating perturbative modes around the vacuum state of the theory. That would be one way to understand it. And so, for example, in 4-dimensional gravity, you can have your vacuum state, your like Minkowski space. And there are 2 different ways that you can have gravitational oscillations, right? It can kind of oscillate like this, or it can oscillate like this. There's kind of like 2 orthogonal ways. You can think of these as like polarizations. In 3D gravity, you have 0. Like you can just do accounting. There's no degrees of freedom present except topological stuff. And in 2D gravity, you have less than 0, which just means that there's no propagating degrees of freedom, right? That it's heavily constrained. Do neutrinos participate in anything after beta decay? Not really. I mean, like, they can interact via the weak nuclear force, but that's the interaction that's associated with beta decay anyway. Have you been to Cambridge and will you come? Yes, I have been to Cambridge. I was in Cambridge in the fall of 2024, I want to say. No, maybe it was the fall of 2023. Yeah, fall of 2023. No, it was... Perhaps, did I go to New Zealand last year? It was? Okay, so it was fall of 2024. From Cameron Snagowski with the $5, wouldn't it be special pleading only accepting mathematical abstract objects and no other domains abstract objects? I don't know if that's special pleading. I don't know why it would be. Like, if you can make an argument for why mathematical abstract objects exist, but there aren't arguments for, or there aren't good arguments for why other things exist, then it's not special pleading. And from Safari Jim with the $5, can we rebuild a collapsed wave function back to an interference pattern from double slit experiment? I don't know what you mean by rebuild. Once the wave function has collapsed, assuming that you take a collapse interpretation seriously, you have to like do stuff to it, and it can like go back to, it can like change again. If you like allow it to propagate and you allow it to interact with various things, it can change in other ways. But like, you can't like reassemble the collapsed part or the uncollapsed thing from the collapsed thing without having multiple different pieces of data about the collapsed thing. So if you have like a trillion identical states and they all collapse, then you can reconstruct the uncollapsed state from the states that they collapsed into. That you can do, but you can't like physically rebuild it. Why don't objects grow if the universe is expanding? Because the forces holding them together are too strong. Or rather, the forces expanding the universe are too weak. Is time... Is time like a wave? Would that be why we experience it linear? No, I don't think time's like a wave. Sorry. From Reliant K with the $5, are you currently researching anything interesting? Where can we find your published works? You cannot find my published works because I don't make that publicly available for from my TikTok audience, or my TikTok or YouTube audience for that matter. However, this does give me an opportunity to shill if you do want to support my research, which, you know, I have like 4 projects that are currently ongoing, and I'm looking to start like 2 more projects. If you want to support my research, like actually support scientific research rather than just donating on YouTube for like live streams, there is a way to do it. If you go to Patreon, there is a like a super high tier version of Patreon where you get to be like a medieval patron of like a scientist, like, you know, the Medici family was to Galileo, right? And you can just fund my research. It's super expensive, but in return, you get acknowledgements in all of the publications that I make. You know, I have quarterly research meetings where I tell you about what I'm doing, and, you know, it's private Q&As and all of that stuff. So if you want to do that, by all means, you will also get access to all my previous research and so on. But otherwise, I'm going to keep that to myself because I don't like getting doxxed. I don't like having my private information spread apart. That's all. From Kevin Bacon with the 5 Australian bucks. What did Big Bang expand into if there was nothing else? Up its own ass. And how did they measure the sun? Have to measure it at night. It's too hot. That's 2 wildly different questions, but we can answer them. Thank you for the 5 Australian dollars. So the Big Bang isn't expanding in the sense of like a thing with an edge where the edges are getting further away. That's not the sense in which it's expanding. The way it's expanding is that the distance between things is getting bigger. Now, whether or not the universe is infinitely large or is finite but has no edge, that can still be the case, and we can describe this mathematically in a particularly nice and concise way. It uses something called a Friedman, Lemaitre, Robertson, Walker metric. It's a perfectly good description of this kind of expansion. I understand that it's not intuitive, but sometimes Riemannian geometry isn't intuitive, or pseudo-Riemannian geometry. Second question, how do they measure the sun? If you're talking about measuring its size, well, you can just put a filter over your telescope, and then you can measure its angular size in the sky during the day. If you're talking about like how to measure like its temperature, like I'm not really sure what you're asking. We can also measure distances to the sun using things like transit times from Venus. So Venus sometimes passes in front of the sun, and depending on where you are on the Earth, the amount of time it'll take for Venus to transit will differ because you're looking at Venus at a different angle as it crosses the sun. And so that can give you details about how far away Venus is, and then you can use that to figure out how far away the sun is. Hopefully that helps. From Sickle Steven with the 27 Swedish krona, thank you again. I'm just here because of Star Trek. Want to learn. Star Trek is great and more people should watch it. Big Bang is the creation of distance needed for heat. I don't know what that means. Dr. Blitz, in the simulation video, you said empty space contains a lot of information. In what form? It's basically buried in like quantum fluctuations of the various fields and the spacetime itself. That's the idea anyway. Is string theory falsifiable out of curiosity? Yeah, in principle it is. We just don't have the equipment to do so. You kicked the can down the road to Venus. Oh, well, no, I mean, the point is once you measure the distance to Venus, then standard gravitational laws let you establish the distance from the Earth to the sun. You can just use Kepler's third law, I think, which relates the amount of time that an object orbits another object to how far away that object is from each other. So, and basically there's a constant. It's like the period squared divided by the semi-major axis cubed is constant. And so if you know the distance to one planet, and you know how long it takes for that planet to go around the sun, then you can use that tells you what that constant is, and then you can use the amount of time it takes the Earth to go around the sun to figure out how far away the Earth is from the sun. Do you think there were any direct collapsed black holes in the very early universe? Do you think also that there were stars way more massive than currently mapped on the HR diagram? So I kind of lean towards the supermassive star picture rather than direct collapsed black holes, because supermassive stars are a little bit simpler to, they're a little bit more in line with the physics that we're familiar with, but direct collapsed black holes at least seem plausible. Why Venus though and not Mars? Because we can never see Mars pass between us and the sun, right? Venus is closer to the sun, so sometimes we will see Venus cross through the sun. We will never see Mars cross in front of the sun, not through, in front of, because Mars is further out. How are you going to know how far it is to Venus, though? Using the transit times. The transit times, so you basically are using parallax. From the transit times, as it crosses the disk of the sun, you will get different transit times depending on where you are on Earth. And then you can just basically use trigonometry between where you are, like the distance between the two people making the observations at the same time, and the transit times. The transit times will give you essentially an angle, like an angular difference between the two. Basically, if you're lower down, if you're further south, then Venus will appear that it's higher in the sky, so the transit time will cross a wider part of the sun than a narrower part of the sun, and so the transit time will take longer. Anyway, that's how you can do it. This is how it was done. I think it was done in the 1700s or 1800s. Now we can just use like radar on Venus, right? But or we can just like use telescopes to like measure the distance to Venus using parallax without using transit times. But yeah, absolutely, we can measure the distance to Venus a lot more effectively now than we could a few hundred years ago. From Judy Basso with the 10 euros, just saying thanks. Well, thank you. Is water wet? It is. What have you done, or what are you working on for work? So I do relativity things. So these are things that involve black holes. I do things that involve like early universe cosmology. I do some things involving quantum gravity. I also do some things just that are on like pure mathematics side, like conformal geometry and hypersurf or submanifold embeddings. Use radar on Venus? Well, yeah, we can bounce radio waves off of things and time how long it takes to get back. I'm pretty sure that this has been done. Yeah, this is a thing. This is a thing that's been done. Carissa Wieland with the 50 gifted memberships. If you guys don't know what that means that 50 random people in the Dr. Blitz Debunks, this the horizontal viewers, 50 random people now have access to a month's worth of membership, which means a month's worth of using the emojis and a month's worth of access to my debate notes, which, you know, I use them personally. They have all of my sources and facts and arguments and counter arguments for debates and stuff that, you know, I just to keep track of my stuff. That's, you know, it's like $4 or $5 a month, and Carissa just sent 50 of them. So let's get a big round of applause, a big whole bunch of W's from Carissa. There's like, what, 700 people in here between across all platforms. So let's see if we can get at least 100 W Carissas here if we can, because Carissa deserves them. Sucks to be vert indeed. How do I get a gift membership? You just got to be one of the lucky receivers, I guess. Thank you again so much, Carissa. I'm getting pirate software vibes. I don't know why people compare me to him. Like I don't know what the commonality is. Is it just because we're both men who do live streams? Like, since energy can't be created nor destroyed, how can we say that perpetual energy isn't theoretically possible when we can just recycle energy? Perpetual energy is more about how, like, perpetual energy is about creating a system that has motion in like a repeated way. So like, it's not just a thing moving, but it's like a thing moving in a circle or something like that, without requiring any input source. And typically, people want it to actually output energy. But energy conservation says that you can't make it output energy if you're not giving it any energy. Be honest, how many questions that you want to answer do you miss? Probably a lot. I can only answer so many. The hair, the glasses. So is it just like guy with glasses and long hair is pirate software? Yeah, I would never wipe a raid. What is the cheapest way of a vehicle to run on Earth? The cheapest way? Probably solar power. From Saikira Novala, thank you for the 100 rupees again. In many worlds interpretation, doesn't universal wave function run out of quantum behavior after it is split so many times? I don't know what you mean by run out of quantum behavior, but no. Are you atheist because you're a physicist, or are you a physicist because you're an atheist? Neither. They're not related to each other. Dr. Blitz, you do have to turn on accepting gift memberships on YouTube to get gifted one. That's a good point. That's a good point. If you guys want to if you want to receive a gifted membership, you have to turn that on, I guess. Let's jump down to the bottom so I'm not too far behind. A trillion divided in 1 million is a million. Why is the vacuum energy so small compared to quantum predictions? Because I suspect the vacuum energy has nothing to do with the quantum 0-point energy. I imagine that they're unrelated. Would you have a look at Alan's Space Audit's celestial theodolite hypothesis, which they think proves flat Earth? It's a complicated method and they need blitzed. Look, they've been basically trying to construct a flat Earth model for literally years at this point. And because we keep getting new data that disagrees with their models, they keep having to basically violate Occam's razor over and over again and make the most complicated models imaginable. I haven't heard of the celestial theodolite model or the celestial theodolite hypothesis. I imagine it's more of the same though. And typically, by the way, like I've spoken with Alan before, Alan basically doesn't understand relativity. So anything that he says about relativity can usually be dismissed as he doesn't understand what he's talking about. Do you believe in volcanoids, asteroids between the sun and Mercury? I have no opinion on them. No, the Earth is flat for sure. Whatever you say, man. Cars can run on compressed air. I guess they can, but then you have to compress the air, right? I've read about cosmological black hole theory. What are your thoughts on the model? I don't think it's true, and I don't think that we have any evidence that supports it. Why does every dude on YouTube Live have face tattoos? I don't have face tattoos. The UN map is model of the flat Earth. If that's their model, then it was destroyed by the final experiment. Alan doesn't understand a lot of things, but yeah, he's woefully uneducated in relativity. Yeah. The thing is he is standing atop Mount Mount Dunning-Kruger as far as relativity is concerned, which is really not great. Dr. Blitz, can you speak to the data coming back from the digital Sloan survey and what it means about the cosmological constant? I haven't seen new data that's been produced by the Sloan Digital Sky Survey with regards to the cosmological constant, so I can't really comment on it. Water requires a container. Earth literally can't be a ball. Come on. Yeah, the container's gravity. Hi, Dr. Blitz, what are the current explanation for entanglement? I don't know what you mean by current, but the explanation for entanglement is merely that you have two quantum systems that interact and therefore can no longer be separated. They become one quantum system, despite being potentially spatially separated. Most interesting astronomical object. Most interesting, I don't know, but something that's really interesting is Przybylski's star, which seems to have really, really heavy elements in it for some reason. And it seems to be like a unique star in that regard. So you're saying relativity is a law? Well, no, it's a theory. But theories are kind of bigger than laws. From Blanc's F4s with the $5, new schedule means I can catch these lives better. Just a thanks for being a good source of science as the world's been spiraling. Well, I appreciate that, Blanc's. A scientific law is a mathematical description. It isn't a fact of the universe, it's a description. Well, I mean, if it's a correct description, then it is a fact, right? Anyone can see the Earth's curvature, the Earth's curved horizon from the summit of Mount Kilimanjaro or Mount Mauna Kea. I've seen the curve from the latter, QED. Fair enough. Can you explain a skyrmion? No, that's condensed matter stuff, and I don't know condensed matter stuff. Gravity equals theory 100, not fact. Theories can be facts, or at least theories contain facts. Theories are explanations, they're not like descriptions, right? But there is something called the phenomenon of gravity, that's an observational fact. And there's something called the universal law of gravitation, which is a law of physics. But make of that what you will. Would someone falling into a large black hole be able to know when they cross the event horizon? Not if their eyes are closed. So you're willing to say relativity is unproven? No. Relativity is like super well supported with evidence. It's just not in the, like, it's a category error to call relativity a fact. Like relativity is like, you could call it a model, you can call it a theory. Those are like, how do I want to explain this? If I give you an explanation for why something is the case, explanations are not facts of the matter about the thing you're describing. Explanations are explanations. Facts would be like the sky is blue. The theory of Rayleigh scattering would be an explanation as to why the sky is blue. So you're kind of getting like the categories confused here. Dr. Blitz, can you explain Goldstone's theorem? Not without refreshing my memory on Goldstone's theorem. This is the thing, this is a particle physics thing and how we get Goldstone bosons, right? Somebody just said the sky isn't blue. Okay, brother, whatever you say. All scientists believe the universe had a beginning. What's your source for that info? Oh, okay, no, that wasn't a question for me. Are accepting requests? Nope. Isn't water on Earth a set amount? I mean, yeah, basically. I want to know about imaginary time on a more intuitive level. There's not really a good intuition there. There's just not. Sky isn't blue. That is refracted light. Those are water droplets turning blue. Well, it's not water, it's Rayleigh scattering. But what does it mean for a thing to be blue if not the light that it gives off is blue? Like, I don't know, man. Do you prefer special or general relativity? Well, general relativity is more general than special relativity, so I prefer general relativity. What's your opinion? What could be the theoretical smallness limit for transistors as physics would allow as we move to GAA and beyond? Could we ever get to a complex computer as in Star Trek? I don't know. This is very much like applied physics stuff that I don't know. I imagine that we probably can't go smaller than a few atoms though, which would then make our transistors like the 1 nanometer size, maybe a teensy bit smaller. Do a flip. The sky is red and purple and yellow orange ocean. Well, look, sometimes the sky is that, but like when it's daytime and it's not cloudy, the sky's blue. Which other field of science do you respect the least? Like nutritional science? I don't respect any field of science like the least. It's like all science is valuable. I should get an honorary doctorate in the field of not having a PhD. I'm pretty amazing at it. Nice. All right, Mr. Physicist. It's Dr. Physicist to you. I have a question. How is your day going so far? I have a headache and I'm very tired and I have a very busy day today. Makes sense to me. A ball of water will never make sense to me. Well, look, something not making sense to you doesn't make it not true. It's the unfortunate reality that some things require like a wee bit of thought to understand. Does gravity hold the entire universe? And if it does, why don't we control gravity? Well, I don't know what you mean by hold the entire universe. Most of the universe, like the structures in the universe, are bound together gravitationally. I don't know why that would mean that we control it. We're just things in the universe. We're also, you know, bound to our planet by gravity. Dr. Blitz, can you explain the Hairy ball theorem? Yes, I can. So, the Hairy ball theorem, let's just talk about it in 2 dimensions. If you have a sphere, surface of a sphere, and you draw an arrow on that sphere in such a way, you draw arrows at every point on that sphere in such a way that those arrows never spontaneously change direction. It's always smooth and gradual. You cannot cover the entire sphere without there being at least one place where the arrows have 0 length, where the arrows disappear. From just some guy with the $5. Did you see the pic of the singular atom that they shot with a laser that made it so intensely bright that we can see it with the naked eye? Yes, I have. You're not seeing the atom. You're seeing like the excitation of the stuff around the atom. It's really cool though. How come you can't prove curvature on ocean water? You can. That's why things disappear bottom up. Look, guys, so we are a few minutes over of when we usually end, and I have a phone call that I need to get to. I told them to call me back, so I have to go. I have to end the live stream, but I will be back. Actually, I think I have to take tomorrow off because I have a doctor's appointment in the morning. So I might do a later stream tomorrow afternoon, but the normal stream tomorrow will have to be canceled. So before I go, make sure to join the Discord. If you're 18 years or older, go to discord.gg/drblitz. It's just Dr. Blitz. And I'll see you there. You'll get announcements. You'll get video announcements, live stream announcements. You can talk with like-minded people. Also, consider becoming a YouTube member or a Patreon member. You get access to the debate notes either way. It's like $4 or $5 a month. And it helps support the channel. So I will see you guys perhaps tomorrow, if not tomorrow, then Friday. And take care, everybody. Oh, hold on. Let me double check for any cash apps before I leave. Okay, no cash apps. We're good. Take care, everybody.